So last time class, we looked at temperature and we also looked at absolute zero. So today I just want to take time to explain a new concept, but not really very new. It's thermal energy. And one of the things that are very important as we'll be looking at thermal energy is the concept of heat. So heat generally is defined as a flow of thermal energy, and this flow generally is due to temperature difference. When I mean temperature difference, I'm saying that heat will not flow if the temperature between two objects are not are not different. So for example, if object A is at a higher temperature than object B, then it's possible for heat to flow, thermal energy to flow from the object that has a higher temperature to the one that has a lower temperature. So there must be a temperature gradient between those two bodies before we can see heat flow. So like I said, it flows from a higher region of a higher temperature to a region of a lower temperature. Now, so in this case, we're just looking at two pots, one filled with water to the brim, another filled with water just halfway. And the question that they're asking us is that between these two stove, which one is going to have a higher temperature measured by the thermometer? Now it's very clear that this the first stove has a higher temperature than the second stove. So the question is, what makes, if we apply the same heat to those two pots, why is it that the temperature in the first pot is higher? And I'm going to explain that as we go further, but it's a very, very important aspect. We always see it every day when we are cooking or something like that. We always see that when you want to cook something, generally it's better to have less water than having more water, but I'm going to explain that as we advance. Okay, so let's look at this question. Now, when the same amount of heat is added to each of the two containers of water, the temperature increase in each will, well, remember we said that, well, it doesn't really depend on the heat that you add. If the same amount is added, well, what will make the temperature to change will be based on what? The amount of water that you put. So the answer will be B, because I mean, you can even see that the higher the water you put, the lower the temperature is going to be. The lower the water, the higher the temperature is going to be. So these we talk about various units that we can use to measure thermal energy, and we already explained that heat generally is energy in transit, and the measure it's used, the unit is also the same unit as energy. And we remember when we were talking about work, power, and energy in a couple of months ago, weeks ago, we said that energy is measured in joules, so too is work. And here we're saying that heat, which is energy in transit, is also measured in joules. And another unit that we can use is the calorie. We have a relationship here between the joules and the calorie. 4.19 joules is the same as 1 calorie. And what do we define a calorie to be? We say that a calorie is defined as the amount of heat that is needed to raise the temperature of 1 gram of water by 1 Celsius degree. That's basically what 1 gram is. And if we define the unit for a calorie, 4.19 joules, to be equals to 1 calorie, so what we're saying is that 4.19 joules of heat is needed to change the temperature of 1 gram of water by 1 degree Celsius. You understand? So that's basically the definition. And here you see the different suffixes or prefixes that we can have. 1 kilocalorie, or calorie with the capital C, is heat needed to change the temperature of 1 kilogram of water by 1 degree. So it's still the same thing that we've been talking about, that we talked about in the same slide. So let me try to summarize everything that we have said so far. Heat is energy in transit, and heat is measured in joules, calories, or kilocalories. So 1 food calorie equals 1,000 calories. Now, do you see the difference? The difference is with the uppercase and the lowercase. The uppercase is actually a kilocalorie, and the lowercase is just normal calorie. So we're saying that 1 food calorie with an uppercase equals to 1,000 calories. To the Weight Watcher, the peanut contains 10 calories. So we're saying that to scientists, the peanut releases 10,000 calories. That's 41,900 joules of energy when burned or digested. I'm going to explain that further. So let's try to answer this question. The quantity of heat needed to raise the temperature of a certain substance, a specific amount, is 1 calorie with an uppercase K. So don't forget, 1 calorie here means 1000 calories with a lowercase. This is the same amount of energy as 1000 calories. So the answer A is correct, and B also is also correct, because we said that 4.19 joules is the same as 1 calorie. Remember? So the answer there will be both of the above, which will be C. Okay, let's look at this question again. You heat a half cup of tea and its temperature rises by 8 degrees Celsius. How much would the temperature rise if you add the same amount of heat to a full cup of tea? What do we think? Is the temperature going to decrease, increase, reduce, or what's going to happen? And we see that the temperature is going to decrease by 2 times. You know why? Because now the temperature, the heat that you place on the cup is distributed over a large amount of water. We're going to explain this further. I think it's something that you guys have noticed with coffee. If you heat a hot coffee in a teacup and it's just halfway in the teacup, and you measure the temperature, you see that the temperature will be really high. For example, and then if you filled with cold tea to the brim, if the teacup now with the cold tea to the brim, the temperature generally is going to decrease, because now the higher temperature is distributed over the entire body of the tea, the cold tea mixed all together, and it drops the temperature generally by 2. So we should expect to have 4 degrees in this particular case that we have been given. Now the next thing that we're going to look at is thermodynamics. The laws of thermodynamics. Generally, we have 3 different laws in thermodynamics. I guess in this syllable, we'll be talking about just the 2 laws, maybe 3 laws, but we're going to see. So thermodynamics, generally, it's just the movement of heat. Thermo, heat, dynamics, how it moves. So the word thermo means heat. Dynamics means movement. So general thermodynamics generally that concept that tries to study the movement of heat. So the first thing we're going to talk about is the first law of thermodynamics, and it's very easy. I guess you guys, I think you guys can really understand it. So when heat flows to or from a system, the system gains or loses an amount of heat equal to the amount of heat transferred. Okay, now this is what it means. Now if we have a certain object, let's call this object A, and let's say heat flows to object A. Let's say this is A object. A heat flows to and B. 2 heats are entering into an object A, or this object, this stone, whatever the case may be. So what we're saying is that from the first law of thermodynamics, when heat flows to or from the system gains or loses an energy that is the same as the amount of heat that is transferred to it. Do you understand what I'm saying? The same energy that enters the system is the same energy that leaves the particular system. Do we get it? So if for this particular object, if A is entering and B is also entering, and what is actually leaving this system is C, we are saying that AB should be equal to C for the first law of thermodynamics. More specifically, heat added. If you add heat to the system, what is going to do? 2 things are going to happen. It's going to increase the internal energy of the system, and it's going to cause that system to do external work. So the exact heat that is added, so generally let me put this as D. So D will represent the energy of this system, and C will represent the energy that is done, the work that is done by that system on the environment. So that is generally a statement of first law of thermodynamics, and we can also talk about energy that can never be created or destroyed. So in the next couple of videos, we'll try to explain the concept of thermodynamics more clearer, so that you can understand what's really happening. So watch out for the next video. See you guys.